Our second example of division of polynomials is also a long division problem. You can see the problem stated here. We're to find the quotient and remainder for the division problem stated. It's a third degree polynomial divided by a second degree polynomial. And let me remind you again that you can pause this at any time to catch up, to write things down, and then continue. I've set the long division problem up, and as we did in example 1, we need to compare in fact, before we compare, let's make sure that we understand that both of these polynomials are written in standard form. That is, the largest degree to the constant, which is degree 0. Largest degree of the polynomial term to the constant of the polynomial, so again, which is 0. Now, we compare the largest degree of the divisor, the term of the largest degree of the divisor, to the term of largest degree of the dividend. We ask how many times will 3x squared go into 9x cubed, or stated differently, what do we multiply 3x squared by to create 9x cubed? And of course that's 3x. And so we decide where we're going to put that 3x, and we put it in the column of x to the first power. So we'll write our 3x right here. Now remember, now we take this 3x and we multiply the whole divisor with this 3x. And so we multiply term by term. 3x times 3x squared is 9x cubed. Then 3x times negative 5x is negative 15x squared. And then 3x times negative 2 is negative 6x. After we've done this, we're prepared to subtract, and so we draw our subtraction bar. Now, let's make clear the subtraction that's taking place, and let's try to do it in our head as we see what's going to happen. So what we're really being asked to do is take the polynomial 9x cubed minus 27x squared plus 14x plus 8 and subtract the polynomial underneath, which is 9x cubed minus 15x squared minus 6x. Now we know that we would distribute this negative sign, but let's think of reading this as 9x cubed in the first polynomial, subtract the 9x cubed that's here. So that's what we have in this position. 9x cubed subtract 9x cubed, which of course is 0, and we don't write down a leading 0. So those add out. The next thing we're going to do is take this term, negative 27x squared, and subtract a negative 15x squared. Look what we have here, negative 27x squared, and we're subtracting this term, negative 15x squared. Well, when we subtract a negative becomes plus 15x squared. And of course, negative 27x squared plus 15x squared is negative 12x squared. So the result we get here is negative 12x squared. Remember, that was because this gave us a negative 12x squared. Now let's take this 14x in the top polynomial, okay, and it's a positive 14x. So let's take this 14x and subtract the negative 6x that's here. Okay, here's 14x, and we're subtracting a negative 6x. Negative 6x. We'll subtract a negative, becomes plus 6x. So this subtraction actually creates 14x plus 6x. That is, 14x subtract negative 6x becomes 14x plus 6x, which gives a result of 20x. Okay, so that's the reason we would have a 20x in this position, and of course it's positive, so we say plus 20x. Now, what we have left over in the work that we have down here is that the 8 is the remaining term. We haven't considered the 8. There's nothing here that we're subtracting the 8 with, and so that's the same as asking us to bring down the 8. We're just left with a 8 in this position that we have nothing to subtract from. So we say plus 8, and we're ready to decide whether to continue or not. Now, let me let you recognize, before we do this next part of the problem, that we could have done this subtraction term by term. That is, what we do is we take the term on top and we subtract the term on bottom. And the term on bottom or top might be positive or negative. For instance, in this case, the term on top is negative 27x squared. And we're subtracting the term that's on bottom. Well, the term that's on bottom is negative 15x squared. And so it's that subtracting a negative that ends up creating negative 27x squared plus 15x squared, or in other words, negative 12x squared. So we're going to attempt to do this subtraction in our head, and the subtraction is the most difficult step that we deal with. So let's continue now. We decide whether to stop or not, and in this case the degree of the remainder portion is not smaller but equal, so that means we continue with our division. So we ask the question, what do we multiply the 3x squared by to create negative 12x squared? And of course that would be a negative 4. So we find the column of constants and we put that negative 4 in that column. Now we use this negative 4 as a multiplier on the entire divisor, and when we do, then we do one term at a time. Negative 4 times 3x squared is negative 12x squared. Negative 4 times negative 5x is plus 20x. And negative 4 times negative 2 is plus 8. And so now we're ready to subtract. We notice real quickly that the top polynomial is identical to the bottom polynomial, so when we do a subtraction, we're clearly going to get 0. So the answer to our problem, the quotient is 3x minus 4, and the remainder is 0. And once again, let's remember that if we were going to, that was what, 3x minus 4, and our remainder is 0. If we're going to check our work, we would take our quotient, our divisor times our quotient. Well, what was our divisor? Our divisor was 3x squared, 3x squared minus 5x minus 2, would multiply it with the quotient, which was 3x minus 4, and we should get, that's the question, the dividend, which is 9x cubed minus 27x squared plus 14x plus 8. We would do this multiplication to verify that that's in fact what we got. We would do that. If we got the correct dividend, then we would be convinced all of our work was correct. I'll let you do that. Okay, next we're going to see an illustration of a long division problem where there are a few pieces of information we need to catch before we proceed. So be prepared to look at example number 3.